Thank you for joining us here on our first little review for the quiz on clouds, thunderstorms, lightning, tornadoes. Um, so hopefully you've kind of gone through our website. All I'm going to do for our little review is really talk you through the clouds answer guide, talk you through the thunderclouds and lightning answer guide, talk you through the tornado questions, and as well as kind of look over those pictures and images from our practice quiz. So hopefully you've been to our website and you've kind of gotten your clouds packet, thunder clouds questions, and your tornado questions and the practice quiz together. If you don't have them, you can click on all of these links for the answer guides, for the original set of questions, and for the readings that they were based on. So if you haven't used our website to do that, please do so. Let's see where we're at here. Okay, clouds. The thing I really kind of didn't emphasize it a whole lot in class, but really what clouds are, it's just when that moisture reaches the dew point. So dew point, it's been one of those things I've been asking you to kind of keep track of in your journal. But all clouds are formed by the cooling of moist air down to its dew point temperature. And remember, air cools as it rises. We tried to say that it cools adiabatically, meaning as you ascend, as you go up the mountain, it gets colder, but really the pressure decreases as you climb the mountain, as you go up in our atmosphere. When that surrounding pressure, that atmospheric pressure goes down, the air can spread out more, and it really tends to make it colder. That's what cooling adiabatically means. So as that moisture, as that damp air rises, eventually it will reach its dew point, and then that's what we see. So all clouds are formed by the cooling of moist air down to its dew point temperature, the temperature at which air must cool in order for saturation to occur. In other words, when does the moisture in the air come out of solution? When do we start seeing it? When do we see that condensation occur? Because the air is just full enough of moisture based on that temperature. Further cooling causes the water vapor to condense and gradually out of the air as a myriad of cloud droplets. And it's the appearance of those droplets that we use to classify clouds. And also, you can tell a lot by the weather just by looking up in the sky. And that's kind of my purpose here with this. Because remember, you can talk about the weather, you can talk to anyone, anywhere, anytime. Because you share the environment, you share the weather in common. So it's one of those good skills for job interviews, just meeting new people, being in uncomfortable situations. Talking about the weather, it works. So the amount of water vapor contained in the saturated air depends on the air temperature. Cold air is capable of holding small amounts, while warm air can contain much more vapor, much more humidity, much more moisture. So the most common way that damp air cools is really by rising. All right, and that's where we start to see when that moisture gets to the right temperature, that's when we see the clouds. All right, so as far as the clouds go, a lot of it is based on pictures. So I'll give you those same kind of colored pictures. Now remember, a lot of clouds, just look up at the sky, there may be more than one type of cloud. But cumulus clouds are the white fluffy clouds. Let me see here. If the cumulus clouds gets really tall and keeps building, you can start to call it a cumulonimbus cloud. That was our thundercloud, our anvil-shaped cloud. I might put a question about knots on the quiz, but if you think of knots as about miles per hour, they're real close to each other. So for our purposes, that works. But wind speed in knots is really very close to the miles per hour speed. Okay, so the clouds. So the cumulus clouds are light and fluffy, and they really can be anywhere. They could be floating down close to the ground. They can also be found up high, too. You can find some, if we say the cumulus clouds are in the middle level, we could call them alto cumulus. Remember, alto is that prefix for the mid-level of clouds. I would say these wispy clouds, that's kind of the word I use, I call those cirrus clouds. Generally, cirrus clouds are very high up in the atmosphere. If you see the cirrus cloud, it usually means there's high pressure, usually means there's good weather, not a lot of moisture real close to the ground. So cirrus clouds, first thing in the morning, if you see that up high, probably going to be a nice day. Cirrus clouds. Now these would be like cirrus and cumulus. You can see it's a little wispy, but they're starting to accumulate. So I think the book here called them alto cumulus. What do we got here? Okay, stratus clouds. That's this. You know, I kind of said I grew up in Illinois, and a lot different when you get across the river, but we just had an awful lot of gray days, overcast days, hazy days. Think of that as stratus clouds. That's fair for our purposes. Okay, so yeah, here's a picture. Hopefully you've seen this or kind of put this onto your papers, but at low altitude, cumulus or stratus, if they start to get dark, they start to get a lot of moisture in them, everyone kind of recognizes dark clouds as stormy clouds. You could call them nimbo. Like we could say there's nimbostratus, which are like these kind of grayish clouds that are going to be dark and make rain. We have cumulonimbus. So I want you to kind of put this nimbus suffix, nimbo prefix with dark. And you can really attach that to a lot of cloud names as well. So cumulus are fluffy, stratus are all gray, nimbo or nimbus means dark, alto, middle of the sky, middle of the altitude. And then the cirrus clouds are kind of those wispy clouds. And we even really said just a plane flying over it. Arguably, you could see that, you know, the moisture that the plane pushes out of its exhaust makes cirrus clouds high up in the sky. Now, these cumulus towers can build, and we've kind of been talking a little bit about this, where you get this air rushing up into a cumulus cloud, and that starts to build this cumulus tower. This rushing up of air a lot of times is due to some instability and temperature changes happening near the surface. But think you can get cumulus clouds, you get air rushing up into them. That's when we get some of those anvil-shaped clouds or those big giant cumulonimbus clouds being formed. This anvil shape, it really is as simple as the wind is pushing the cloud this way. So that's why the anvil pushes out that way. So, you know, a question on a quiz, if I give you a question and say, which way is this moving? Look for the anvil. All right, now remember, we don't always see it up in the sky. There may be a lot of other clouds or, you know, just trees or buildings. It may be dark outside. So just because you don't see it doesn't mean it's not there. But those anvil-shaped cumulonimbus clouds are going to produce these big thunderstorms. You get a lot of warm air rushing up on this side. The cold air, kind of cold downdrafts occurring over here. That's where you see the rain. Remember where the tornado is going to be right here. This gust front, if you want to think about that. So we can get a lot of these kind of interaction of these winds right here at the surface, and that's what can contribute to a tornado, is this instability here at the surface, but then we kind of watched, or you can see the tornado spiral down from the clouds above. So here's a good anvil-shaped cumulonimbus. Which way is it moving? That way. Whereas the possibility of a tornado to occur would be kind of generated over here in this range. But think of this as cumulonimbus, the cumulus tower building and building and building. The wind pushes the anvil shape this way. The strong warm air is rushing up. These cold downdrafts are rushing down in the clouds. And that's a lot of what we see in that terms of the instability. So just remember, alto means middle, cirrus or wispy, cumulus or fluffy, and stratus are just kind of the all gray. So we'll look at some of these. We looked at a lot of these pictures here in our practice quiz, so I'll pull those back up in a moment. Okay, so let's look at these thunderclouds a little bit more here. So here's kind of the picture we put on the board. Once again, warm air rushing up, cold downdrafts here where the rain is. Now in terms of lightning, the positively charged, charge is a strange aspect, but really as all this kind of condensed water and then ice starts to form and gets all turned around in there, it's just kind of like spinning a bunch of fuzz around like we did, but it creates this separation of static charge. I want you to recognize a lot of the positively charged ice is up in these warm updrafts. A lot of the negatively charged pieces of static electricity on the ice get caught in these cold downdrafts. But it's that separation of charge that leads to lightning. So I do want you to recognize the negatives on the cold down, the positives on the warm up. Okay. A squall line, that might show up on there. Just think of that. A lot of times you can see these thunderstorms coming in, and a lot of times we just call that a squall line. As we look more at fronts in the jet stream, kind of next chapter, we'll kind of look at what forms these squall lines. Or a lot of times you can just look out in the sky and really see some of these front boundaries occurring. Okay, so you've gone through the thunder clouds and lightning, but once again, it's kind of looking at that diagram and identifying warm updrafts, cool downdrafts, where the rain is, where the tornado could show up, where the positive charges are, where the negative charges are, and what direction it's moving in, which way is the anvil blowing. So yeah, hopefully you can do some of those on on those cumulonimbus diagrams. All right, now tornadoes. They can form in a cumulonimbus. I guess for tornadoes, let me actually kind of go look at a few of the tornadoes that I had you guys make. Okay. So yeah, here's a good one. And the thing I liked about these tornadoes is we had to get a lot of instability going on down here at the base of our jar, but you saw it spiral down from the top. It's the same phenomena in the clouds. You get this instability at the surface, but we see it spiral down from the clouds. In some ways, you know, that little footage from Wizard of Oz was accurate in that sense, and that it, you know, was kind of a little movie picture, but it spiraled down from the sky. We saw all kind of like a few storms on some movie I got from our library downstairs. Instability at the surface, you see it spiral down from the sky. That center, if you look at this from overhead, all right, a lot of you guys, there's no water there. You guys were sticking your pencils, your paintbrushes, there's no water down in there. That's where the low pressure center is of the vortex. So I do want you to identify the center of that vortex is very low pressure. That means there's no air. For our jars, that means there was no water. This Doppler radar signature kind of hook echo of a tornado. It is just an overhead view of the spiraling moisture. So please think of the Doppler radar image and this hook echo there as the indication that a tornado is forming. Same thing we kind of had here in our jars. You can think about this moisture spiraling. That's kind of what that image is on the Doppler radar. But once again, that center of the vortex is low pressure. Low pressure. Yeah, here's some good ones. Look, instability at the surface, but it spirals down from above. All right, yeah, here's some other good ones. Instability at the surface, but it spirals down from above. Instability at the surface, spirals down from above. Now that instability at the surface, so we had all this thing spinning around here. I used the term a barrel roll in class, but what that instability is really caused by are those warm updrafts and those cool downdrafts in our cumulonimbus clouds. So let me see here. Sorry, I know it's probably herky-jerky on the internet. Okay, so this giant cumulonimbus cloud. Here's the warm updrafts, here's the cool downdrafts. As that warm air and cool air are mixing, you get this spiraling effect here. So it's kind of barrel rolls at the ground. Warm air one way, cold air the other way. You get this spiraling effect. And if you've ever just kind of stood around as a thunderstorm's approaching, you feel these, whoa, warm air, whoa, cold air, oh, it's windy, so you kind of notice this instability. Now what happens is as this is kind of spiraling here, it gets blown over. All right, and just kind of think of that magnet. I mean, it sounds silly, but I had you guys kind of, that magnet would hop around in the bottom of your jar. But once that instability kind of got all, then once it kind of got itself organized, you saw it really kind of spiral down from above. So we get this cumulonimbus tower building with warm air, cold air falling down out of it, creating a lot of rain, barrel rolls at the surface that can get tilted up or blown up and cause it to spiral down from above. Okay, we do live in Tornado Alley. I'm sure you guys will be hearing a lot about tornado drills we'll be having, I'm sure. Maybe even during our tornado quiz, I bet you we might have a tornado drill. Anyway, okay. Let's go through some of these unknowns from the... And once again, if you called that cirrus cloud, I like it. If you said there's cirrus clouds in that picture, I like it. I would say there's some cumulus clouds too. I would say those are mainly cumulus clouds. I would say those are mainly cirrus clouds. Stratus, gray. Oh yeah, some cumulus clouds. Alto cumulus, maybe, because it's in the middle. Stratus. Maybe even nimbo stratus, because it's dark. Ooh, cumulonimbus. Which way is this one moving? That storm is moving that way. Anvil, the wind is blowing it that way. Where's the tornado possible? Down here. Okay. This big anvil-shaped cloud, that way. Tornado possible down here. Stratus, gray. Stratus, gray. Cumulus. Cumulus. Maybe nimbocumulus. Not quite, but starting to get dark. And this one here, I would say cirrus clouds, maybe a little bit of cumulus down in the corner there. I hope that helped. That was kind of a quick little review of clouds, thunderstorms, lightning, and tornadoes. There will be a little bit about lightning safety. Remember, your car is a very safe place in a thunder lightning storm, but they also say it's really not safe in a tornado. But it's funny when they're caused by kind of the same approaching storm systems. Yeah, but tornado safety, get down to your basement. And the thing I learned was if you're in a basement, make sure there's nothing above you that's really heavy. Like people have been down in their basement, their roofs have been ripped off, their houses have collapsed, and like their big TV or entertainment center or couch falls through the floor that's broken and lands on them. So even though they were in a safe place, a heavy thing landed, and that's usually how people get hurt in tornadoes, is heavy stuff lands on them. But yeah, they say your car is not the best place if you're out in a tornado. I don't know, I struggle with that. I mean, they say get down low, get to a tornado shelter. Also, they say just keep driving. A lot of times you can drive in a direction that the storm is not moving in, so that may help. To try to kind of classify tornadoes, I may ask you, is this be an F0 or an F5? It'd be some obvious ones, but just kind of remember, and we'll talk about Fujita some more throughout the year and kind of his contributions to meteorology. But the F5, I think that Joplin tornado a couple of years ago was an F5, basically. So be familiar with the scale and the wind speeds here and kind of the type of damage that occurs. But like I said, the questions would be, was this F0 or F5? It won't be, trying to pick out something that's a smaller detail. But if you have questions, let me know. We'll do a little review in class too. But once again, try to be familiar with the cloud names. Be very familiar with that diagram of cumulonimbus clouds, and be familiar with some of those aspects on the tornado. So once again, I think the best thing is go through our website and go through the practice quiz, go through the worksheets. I think you'll be in good shape there. So I appreciate your time, you guys. It means a lot to me that you took a moment to watch this. Thank you very much.